It's a short video to show some behavior that I noticed when I modified my lesson 99 solution, which used pull no block in the PIO program, to take that out. I wanted to point it out to everyone, and I also may post something to one of the Raspberry Pi forums to see if someone can explain what I saw. On the left, you'll see my setup. The servo that I'm using here is the one on the left. What you're looking at is what I'm going to use in my video for the lesson 99 solution, so you can ignore the servo on the right. The servo on the left is being powered by an Arduino at this time, using its 5-volt power. Over on the programming side, you'll see I have 3 programs I'm going to run through. The first one, 98-1, is what I did for my lesson 98 solution after taking out some sleep time every time the pulse width value changed. Let's take a quick look at it. And I did point out here at the top, here's how long a sweep took. We're going to see that when we run it. This is the PIO program, same as it was before. Pretty much looks just like Paul's, except I use side set. This was the calculation for how many instructions were run and how long it actually took. This is the slope of the line. I reduced the 2000 over 180 to 100 over 9. The little subroutine that computes the pulse width given an angle. Declaring the state machine. Period, initial pulse width. Prime the TX50, then extract the values into the state machine OSR and ISR registers and the X register for the pulse width. Activate the machine and then enter the loop. I added this instruction and these 3 to come up with some approximate timing. I also have a comment here in case you noticed what I'd done. I intentionally do 0 twice, once here and then once here, and I intentionally do 180 twice, once here and once here. So there's a slight pause at each end of the sweep. I just do a put, and the pull no block will get the value. So let me run it. Takes about, notice the servo's moving kind of slow. There's one sweep. There's another sweep. And here we see it settles down on 7.24. I'll let it finish one more sweep here. Okay, that's the end of that one. And move on to the second program. This is the same as the first one, except I took out the pull no block and I moved the side setting to 0 down to the first instruction in the loop. That means I'm going to have to do that pull in the Python code like Paul did. Everything else here is the same. Down where I did the priming, same settings, except this time I don't have to move anything to the X register. Here's the loop, same loop as before, with an added instruction. We have to do that pull that was commented out in the PIO program in both of these 4 loops. Let's run this one. Watch the servo. Notice it's going a lot faster this time, about 1.44 seconds. Let's stop that one. Move on to the third program. This one is essentially the one Paul showed in his solution that he showed us in lesson 99. When I ran my version of this program, it also took 1.44 seconds, which you'll see. But in Paul's solution, I kind of watched a second-hand move on the wall while his swept, and it seemed to take about 10 seconds. Don't understand that. So here's the modifications to the state machine code. We still have the pull and the side sets commented out. This time we don't set a side set, but instead do what Paul did and use set to set the values to 0 and 1. The decorator for the PIO ASM was changed from side set to set. The state machine definition was changed to use set base instead of side set base. Everything else is the same. Let's run this one. And again, we see moving very quickly, essentially the same speed as the second one. So I'm perplexed as to why the one that has the pull no block ran in 7 1/4 seconds and the other two ran in 1.44 seconds. As I stated initially, I may post something to a Raspberry Pi forum, but I wanted to post it here and see if anyone here has any ideas. Thanks for watching.